Yeah, hi, we are from svsembedded. The project title name is IoT based automated paralysis patient healthcare monitoring using Arduino Mega 2560 and GSM SIM 800L for GPRS internet. So here we are using power supply module, 5 volts power supply, Mega 2560 board, and we are using total 1, 2, 3, 4, 5, 6, 7 sensors we are using. LM35 temperature sensor, body temperature sensor, precious temperature sensor, minus 55 degrees centigrade to 150 degree. It is connected to the ADC 0, and body fault detection, it is connected to the ADC 1 and ADC 2. ADXL 335 MEMS accelerometer sensor, and ECG sensor, it is connected to the ADC 3, and flux sensor 1, flux sensor 2, flux sensor 3, flux sensor 4, 2.4 inches flux sensor, those are connected with ADC 4, 5, 6, 7. And if flux bended, the voice should be output. APR 33A3 voice recorded and playback IC. So whatever the flux bending, according to the voice should be output. 16 cross 2 LCD display, RS enabled D4, D5, D6, D7 LCD data lines. GPRS, it is connected to the RX3 and TX3 serial communication 3. So here we are using one web page. So in that we are monitoring the temperature, ECG and fault detection. Show the data.php. So we can monitor the sensors values, temperature, ECG, fault detection, date and time. So here we are using SIM 800L. You can use Idea, Airtel, Vodafone, BSNL, 2G, 3G, 4G SIM card, SMS balance, main balance, internet balance, and bridge rectifier, filter capacitor, 7805 regulator, 1 LED power supply board, Mega 2560 board, 80 Mega 2560. Then here A0, A1, A2, A3, A4, A5, A6, A7. A0, it is connected to the LM35 temperature sensor. A1, A2, X coordinate and Y coordinate of ADXL 335 MEMS accelerometer. A3, it is connected to the ECG module, and A4, A5, A6, A7, those are connected to the flux sensor 1, flux sensor 2, flux sensor 3, flux sensor 4. 1, 2, 3, 4. And here we are using APR 33A3 voice recorded and playback IC, and speaker we are using. So now here I am going to give the power supply here. 9 volts 1 ampere adapter. Solution for paralysis patient communication. Okay, GSM initializing, GSM connected. So echo, finding network, GPRS main. So we are enabling the GPRS internet onto this SIM card, and HTTP1, HTTP2. So T for temperature, E for ECG, X coordinate and Y coordinate, and normal, and all the flux sensors should be normal. Okay, so now I am going to increase the temperature for one by one. If temperature crosses 50 degree, and we will get the SMS alert and email alert. GPRS sending, sent completed. Here it will update the data, whatever the temperature value, that value should be updated onto the IoT web page. So temperature is updated, sent, OK, completed, and temperature alert. Okay, and we will get one temperature alert. Okay, so we are getting the temperature alert SMS format, and we are going for the fault detection. Right fallen, send completed. Fall should be goes to yes. Yeah, right fallen. And we are getting the email alerts also. Go to email. So here fall detection came. Okay, fall detection came, and SMS alert also came. Okay, temperature alert also came. Okay, Now I'm going to bend one finger. Water. We are getting the SMS alert. Water SMS alert came. Okay, so I'm going to bend second finger. So now I got second SMS alert. I need food. I'm bending the third finger. Fresh air. So I got SMS alert. So I'm going for the little finger. Washroom. Washroom. Okay, so I'm going to bend 1 and 2 finger. Make it straight, everything. Help. Help. So once again, 2.4-inch flux sensors, flux sensor 1, flux sensor 2, flux sensor 3, flux sensor 4, and GSM GPRS modem, 16 x 2 LC display, and 80 mega 2560 board, Arduino mega 2560 power supply board, and APR 33A3 voice recorded and playback IC, speaker, LM35 temperature sensor, and ECG sensor should be connected to body, and fault detection. Left fallen. Send completed. Fault detection, yes. We are getting the email alerts. Okay, fall left fallen. So fall detection 2.5. So time is 2.5. 2.6. 2.6 came. Okay, if you press it, it will be open. Thanking you. If there is any doubt, let me know to SVS embedded.